Hello, this is Saifat Lectures coming to you today with the topic the origin of continents and oceans. Why do we have our continents far apart from each other? Africa, America, Europe, um, Asia. Why is it huge oceans are between these continents? This is what we're going to talk about today. And it was coined by this gentleman you're seeing today called Alfred Wegener. Wegener was born in Berlin, 1st of November 1880. He studied the natural sciences at the University of Berlin, receiving a doctorate in astronomy in 1904. Wegener first presented his theory of continental drift to the German Geological Society on January 6, 1912. His theory was based on a large amount of evidence from geology to paleontology. And how he gathered this evidence is what we are going to tell the story today. And at the end of the lecture, there will be some additional further readings that anybody who is interested can have a look to read more. One of the lessons in Key Stage 3 in the UK, like year 11 to year 14, year 3, 11-year-old to 14 years old, includes plate tectonics. So if kids 11 years to 14 years are taught about this, I don't know how adults are not able to know these things. So that is why I'm interested in bringing these lectures to the public so that those who doesn't know will know. I'm going to put this in English so that students of geography can gain from it, and at the same time I'll put it in local language in Wolof so that ordinary people can learn to understand why this is. Thank you. So let's start. Now, these are this is the picture of the world. That is the map of the world. You can see the continents. Down here you can see is South America. Over there is North America. You got you got Africa over here, and over there you got Europe and Scandinavia. You got Asia over there, and you got Madagascar down here and Australia over there. So the continents are separated by huge oceans. These are the oceans. All these things you are seeing in dark are blue oceans. So why are they separated? Why is the oceans there? Why are oceans anyway? This is the question that Wegener was asking. And one of his one of the things that he had saw and observed, because as a scientist, before you can make a theory, before you can predict anything, or before you can make any statement, you have to make an observation. First, an observation. Then, from the observation, you see how things work, you observe it, and then you try to understand how it works. And then, after you formulate a theory that, okay, according to the observations, this is the theory, this is what I think happens. And now that theory needs to be tested. If the theory meets the observations, then it is becoming true. You repeat the test again many times to make sure that it reaches the same conclusion. If it does, then you can extend your findings to your further scientists so that they can test it themselves. If they can test it independently of you and they reach the same conclusions as you reached, then it became a fact, and that is a science. Now, but if you formulate a theory based on your observations and your theory does not meet the observations, then it's not a science. You just have to drop that and find another explanation. Another way around this scientific method is as well, after making an observation, You can also make a theory, and that theory should be able to make a prediction of what should happen based on the observations. So if that theory is tested to see whether the predictions meet the observations, then it becomes a scientific fact. If it doesn't, then it is not a science. This is how science works. Right. So one of the first observations that Wegener saw was that it looks like there is a fit between these continents. Look at the edges, the white edges that are marked in white. Um, this is um, this is South America, and this is kind of the western part of Africa. So you can see that they can snugly fit together, and that was one of the things that make him thought that definitely continents must have been together, and later in their evolution they split and separate apart. Okay, that is Alfred Wegener, 1880, was born in 1880 and passed away, died in 1930. And his theory of continental drift is what we are going to explore today. Okay, so but then he needed evidence. As I said, in any scientific observation, before you make before an any scientific observation and a theory that you evolve from that observation, you should have some evidence so that you can convince other people that this is the fact based on this evidence. So he tried to have four concrete evidence that he could use to confirm his theory and his observations. Okay, so one of the first evidences was what I just showed you, is the apparent fit of the continents. You can see down here it says the coastline of the continents appear to fit together like the piece of a puzzle. And that is what we have just seen, that South America was about to fit to Africa. So that was one of the evidences that he had as a first evidence. Now, he need three more evidences to confirm his findings. Now, the second evidence was he tried to look for past life. That is the paleontology part of it. As I said, he based his theory on vast amount of data, vast amount of evidence on geology and paleontology. Paleontology is the past life that existed in the planet, whether they were plants or they were animals, they were living things. As long as they were living things, that is what paleontologists study. Because their remains, when they die, their remains are buried in the ground and later they're found. Like this Mesosaurus that you can see here is a fossil that was found on on a on the rocks, and this fossil, as you can see, there's another fossil of Mesosaurus found in the rocks. There are different types of rocks in the world, but all these rocks that you can see can be categorized into three rocks, three different rocks, and all the other rocks can emerge from these three different rocks. First rock is an igneous rock. Igneous rock is the rocks that came from volcanic eruptions, and they form these basalts and granites and all the rest of it. There are different type of rocks, as I said. So like basalts and granites are all part of igneous rocks, and there are many other different types of igneous rocks, but they are all classified as igneous rocks. The other second rock is metamorphic rocks. There are rocks that metamorphose, they change because of the amount of heat and pressure exerted on them. So they change their structure and their physical composition and their chemistry change because of the amount of pressure and heat they undergo. That type of rock is called metamorphic rocks. The other type of rock is sedimentary rocks. Sedimentary rocks. You can find different type of sedimentary rocks, but they are all classified as sedimentary rocks. And they are the sediments, they are the debris that flows on the rivers, and they are like a little bit of gravel, sand, silt, and things that flows as river pushes it down the stream. As the river is fast flowing fast, it carries these debris along the stream. But where it goes slower and slower, the river goes slower and slower, it starts to drop these sediments down at the bottom of the lake or of the river. So at the riverbed, you can find whatever was carried from the other part of the river being dumped to that side of the river. So at the end, they result in compaction. They are compacted together and they are cemented and they become sedimentary rocks. And it is in these sedimentary rocks that you can find fossils. You cannot find fossils in metamorphic rocks. You cannot find fossils in igneous rocks because they are very hot and they can destroy whatever evidence or fossil that are within them. So it is only in these sedimentary rocks that you can find um, fossils. Okay, so this is another fossil of the Mesosaurus. Now, have a look at it. So Wegener looked at where did this Mesosaurus existed in the planet on Earth. So he saw that these were freshwater kind of lizards. You know, they look like lizards, but they live in fresh water. But how did he know that they live in fresh water? It's because of the stone on which the fossils are found can only be found in freshwater sediments. So that gave the conclusion that these Mesosaurus were freshwater animals. And he can only find them at the tip here of, of South America and the tip here of South Africa. He cannot find them anywhere else in the world. Only these two parts of the world, the Mesosaurus can be found. And if you date them, it's the same date, the same age, the same type of animals existing in these two continents. So that make him thought that these two continents were once together and the Mesosaurus was living in that land. And as continents drift apart, it took them apart. That is why you can see Mesosaurus remains in here and you can see Mesosaurus remains in here. So that was an evidence. He also gathered other evidences which I haven't shown here. That is evidence of plants. He looked at plants. Some plants did exist in some part of the world and another part of the world which are similar to to the same type of plants. If you put them together, it's like they once existed in the same land. So evidence of the fossil record also gave him another evidence of that the continents were together. So that was evidence number two. Identical fossils have been found in the rocks on either side of the ocean. Now, evidence number three. This is also a Mesosaurus. As I look and browse for Mesosaurus, I saw one Mesosaurus fossil being sold at Amazon at €2,000. So you can see um, fossils are a big money making a big money making procedure as they are dug and found and then they are sold to museums. Museums are very much interested in collecting past history, past life, so that they can display them in their museums and people can go and visit. So people make it a living to go to fossil sites and where there used to be limestone or there used to be sandstone where these fossils are normally buried, and they dig for them, found them, and make a fortune out of it. Right. So the third thing that, the third evidence that Wegener was looking at was geologic structures, the mountains, the rocks that are found in different parts of the world, correlating in different parts of the continents, were similar and they were of the same age. Um, how did he know that they were of the same age? That is dating of the rocks using radioactive dating. That we cannot discuss here because radioactive dating is a topic of its own, which I will bring later in these lectures, and to explain how scientists can use radioactive dating to date fossils, to date stones and rocks, and to date past living things, how old they are. So when he looked at the geological structures of the Earth, he saw that mountains around here are the tip of the southern tip of North America, and the mountain ranges around in Europe here, going towards Scandinavia down there. All these mountains are of similar age, and the rocks are of similar type, the same age. So that makes him conclude that these parts of the world were once together, and continental drift has made them move apart to their current locations. So that was evidence number 3. Identical rocks and mountain structures have been found on either side of the ocean. Now he got one more evidence to fulfill his 4 evidences that he needed. And that evidence was past climate data. How was the climate like in the past? First, he looked at glaciation. Now, what is glaciation? Glaciation is the accumulation of ice, um, very deep accumulation of ice, and it happens in the mountains going downwards, because high up in the mountains is cooler than down at sea level. Because the more you go high up, the weather or the climate become colder and colder. Why? Because at the top of the mountains, you have less air because the air expands. And for it to expand, it needs energy to do that. As we all know, in physics, energy is the ability to do work. You cannot do any work, you cannot move anything, you cannot do anything without energy. So if you take a cup of water, for example, and put it down on a table, it stays there. It wouldn't move until you move it yourself physically. There are different types of energies. You have mechanical energy, you have electrical energy, you have chemical energy, you have nuclear energy, you have wave energy. Yeah, there are different types of energies. But energy must be used to do work. Energy must be used to move something or to get something to happen. Okay, so that is why at the top of the mountains, the energy, that is the heat that was in the air, was used to expand the air, makes it wider and occupy more space. And in that case, you have less heat in the air, and that area becomes colder and colder. And ice accumulates there more and more faster than it does at sea level. Now, as the ice accumulates, there is a period of time in the seasons that the ice starts to melt. And when it is melting and it has been accumulated to a depth, a very high depth, and it's a very heavy piece of block of ice, it will start to slide down. And when the ice was deposited, at the bottom of the ice where it meets the surface of the rocks, there are pebbles, there are rocks, there are different type of pieces of materials that the ice had covered there. And because it is covered, when the ice is moving, it's dragging those pebbles, those rocks, those pieces of debris it drags them along as it slides down the mountain. And it is that dragging of the glaciers that makes these marks on the rocks, and that is called glacial striations. So this is what he was looking for, the striations, these marks. And look at this one. How these marks, if you see these marks anywhere, just know that that area must have got glaciers before in the past. And it is the glaciers that were sliding down that bruises and gouges and create these marks on on the rocks, on the surface of the rocks. Okay, so then what he saw again was that there were glacial striations in the equatorial forests where there is a rainforest like Africa. In Africa here, this is a rainforest area. This band that you see, this green band, is a rainforest area where you have green vegetation. And here also in South America, this green area here is also a vegetation band where you have greens growing there, thick bushes. Now, but how can you have glacial striations on the vegetations in the tropics, in the tropical area? How can that be possible? So he thought about that and he questioned it. And he thought, no, you cannot have glaciers in the equator. How can that be? So it must have been that in the past, these parts of the world were located in colder regions, so far to allow glaciation to take place there. And it is when those glaciers were melting that glacial striations were formed. That is why he could have found glacial striations in the rainforest. Okay, so then another past climate data is the evidence of bituminous coal. This coal is what we use in Europe. It's different from the charcoal that we use back home, where we burn wood, and from the wood we have charcoal. This coal here, is coal that was formed during the Coniferous era, billions of years ago, when the land first started to have plants. And it is those plants, those ancient plants, that died and get buried over and over with layers and layers and layers of rock and sand, that the pressure on top of them and the heat on top of them has caused them to turn into coal. So this is bituminous coal. So he found bituminous coal as well in areas where there is coal today, presently today, where there are coal regions. And bituminous coal must have been from a thick vegetation. And it's the vegetation that died and be buried to form this coal. But if he can find bituminous coal in coal areas of the planet right now, then how can that be possible? Because cold climate cannot have that thick vegetation. So then that also became another evidence for him that that part of the world must have been in tropical areas so that vegetation can grow there, like this area. You can see how thick the vegetation is, the bushes, and these are the things that can grow in tropical areas and not in colder regions, like in the poles, in the polar regions of the world. Okay, so then past climate data became his fourth evidence. Coal has been found in cold regions, and glacial evidence also have been found in warm regions. So which means that the continents have moved their locations to their present locations right now. So there you go. So he got his four evidences that he can use to present his observations. And then he wrote his book, The Origin of Continents and Oceans. Yeah, so Wegener presented his theory of the continental drift to the German Geological Society on January 6, 1912. But then, He was asked this question. He could not explain what forces were driving the motions of the continents. When he was asked, okay, you've collected all this information, you've shown us all these observations you have made, but how can these continents be driven apart? What is the mechanism that was driving them apart? That Wegener could not answer. And so his theory was rejected. The scientific community did not accept his theory because he couldn't prove how these continents were driven apart. However, but this happens in many scientific observations. Many scientists have started some things that they couldn't continue. They formulate they observe observations, they formulate theories, and but they couldn't continue. Their lifespan expires. They died, but then future generations came and pick up on their stories and then develop upon it using new materials, using new observational tools, and using new experiences that they have gathered in their generation to further continue the confirmation of that theory, to disapprove it or to approve it as a scientific fact. This is how science goes. So then, unfortunately for Wegener, his theory was not accepted. He died in Greenland in 1930 um, when he was exploring polar air masses, how those polar air circulates. That was what he went to explore with his team. And one day, as the story goes, he went out to look for food for his team, and he never came back. And later, he was found dead in the ice in the snow. So Wegener was buried in Greenland. Today, his grave is still yet in Greenland. And that is how his story ended. Very sad. He died 50 years old. Okay, so now continental drifts still yet do happen. Look at this one. This is in Africa. You can see how this part of Africa is breaking up. It's like a part of Eastern Africa is breaking up. And this breakup will take millions of years to separate to form new oceans. There will be a new ocean forming in Africa, calling maybe we call the African Ocean, as we call the Indian Ocean. And as it breaks on the land and it goes through into the ocean and it breaks into the ocean and water will flow into this gap and then rivers will form as it widens. Seas can form as it further widens, and you can have oceans. So this is how oceans are developed. Okay, look at it. This is staggeringly scary, as you can see. And this also can cause what we call speciation, which I will explain later in another topic, in another subject, in another lecture. I would be able to use this to explain how species evolved. Okay, and this is where these the countries that are going to be affected if Africa has broken apart. These countries currently are landlocked, but when the continent breaks apart, eventually, it's Uganda, Democratic Republic of Congo, Zambia, Mozambique, Malawi, Tanzania, Burundi, Rwanda, Kenya, and Ethiopia are the ones that will benefit from this ocean that is going to form. So new economies will form, and new ocean transits can be formed. Okay, and this is how eventually it may look like. This is Africa as a whole, and this is where the break is starting. And you can see water, the blue ocean is starting to get in there. This is how eventually, it has not yet, but eventually is how it is going to be, because the movement of the plates is so tiny. It's maybe 1 inch per year. 1 inch per year. So you can see the Atlantic Ocean, how big it is, the Pacific Ocean, how big it is. If they were together, and eventually now they are this distant apart, and they've been moving at 1 inch per year. Tell me now how many millions of years that would have taken for it to be at its present location. And scientists can date this, and they can tell you how long that ocean have started. And in our next lecture, we're going to explain what Wegener did not see, what Wegener was struggling to prove to the scientific community, and now it has been taken up by new generations of scientists and new exploration methods, and they confirm that Wegener was right. And this is what we will be discussing in our next lecture. I will be also explaining this in local language so that people who does not understand the English capacity will be able to at least have a gist of what is happening. Now, these are references and further readings for people who want to read more about this. Um, this link here I have given will show exactly how glaciation can drag on can drag on the floor of the rocks and can cause exactly glacial striations. If you can get into this link, there is a little bit of a demonstration that will show you exactly how glacial striations are caused by glaciers moving. Okay, I will advise also for further readings The Origin of Continents and Oceans of Wegener, that will teach you more about this continental drift. This program, I have got it through the courtesy of the Art Science course by Mark Samantano online, which I have used to explain this. So thank you very much for watching.